Hello, ladies and gentlemen, girls and boys of all ages. We are here to do some math. My name is Roger Whitesell. It is December 13th, 2020. And today we're going to do a little bit of work with exponents. This is something that is most likely going to be on the ACT and the SAT. So let's just make sure we review a few of the rules of that. So at this point, I'm going to share my screen, and then we're going to pull up an example here. So we are dealing with this. So we've got negative exponents, we've got numbers on the top and the bottom, and we want to try to figure out how to approach this. So when we're combining exponents, if we have, let's just say we're just going to give the example of, I'm going to just, let's see here. If I do this, can I raise that to a power on this? Let's see if I can. So I'm just going to draw it in. Let's just get rid of this. And I'm just going to give a couple of examples here. So if I have x squared plus x squared, I don't do anything with the exponent. What I'm looking for is the same base. When I have the same base, I can combine these. So I'm going to have 2x squared. Now, if I had x squared times x squared, now I'm going to add the exponent. So now I'm going to have x to the 4th power. We have some negative exponents here. What do we do in that case? So let's say that we have x to the minus 4. What does that mean? That means that we have 1 over x to the 4th. And just a way of working with these negative exponents, let's say that I had x squared over y to the minus 2. When I'm dividing, or if it's in the denominator, I can move it to the other side of the division sign and just simply change the sign. So since it's on the bottom, I'm going to move it to the top and change the sign. So this is equivalent to this. All right, so that was our little review. Let us now see if we can make some sense out of this problem. Well, first of all, I'm seeing that we have both the top and the bottom are powers of 3. So let's rewrite the 9 as switch to drawing as 3 squared. And that is raised to the minus 4 power. On the bottom, 27 is the same as 3 times 3 times 3. That's equal to 27. So 3 to the 3rd power is equal to 27. So I'm going to replace 27 with 3 to the third power and take all of that raised to the minus 3. When we were reviewing the rules, I forgot to mention what we do if we have a power raised to a power. When we have that situation, we multiply the exponents. So we can rewrite this as 3, 2 times minus 8. I mean, the minus 4 is going to be minus 8. And that's going to be, again, we're going to do this times this. So that's going to be 3 to the minus 9. All right, like we said before, when we have negative exponents, we can move it to the other side of the division sign. This is going to be a matter of just taking this and putting it on the top. And again, we change the sign. So we're going to have 3 to the 9th. This is going to go to the bottom. So we have 3 to the 8th. So now we can see that 8 of these will cancel with 8 of those. So we'll have 3 to the first power. And our answer will be just 3. Okay, we're going to uncover. Let's just pretend that we did this at the very beginning. So I want to say that we covered all of these up at the beginning. Let's say that we covered these up. And then we worked out our problem to see what we came up with. And we came up with an answer of 3. We didn't want to be biased because sometimes it's, I guess our line thickness is too big here. Let's go with that one. So at this point, we have an answer. And let's just so let's do it in black here. So this is the outcome we had. So now we're going to remove this blackout here. So let's just erase that and that and see if this matches any of these. So the first one says 1/3. That's not a match. Second one says 1. That's not a match. Third one says 3. That is a match. And we're just going to go through all of them just to make sure we haven't omitted some concept here. 3 matches this, so 3 is the answer. All right, let's review what we learned today. What I want to do at this point is to just remind you of the couple of rules that we did today. If we have x squared plus x to the third, I really can't combine those. What I'm looking for is x's to the same power. So if I had 2x squared, I have x squared on both of these, so I could add these together to be 3x squared. All right, the rules start to come into play when we have multiplication. So if we have x squared times x squared, what we're going to do is to add the exponents. They need to be the same base. We're going to have x, and then we're going to have 2 plus 2, so that's to the 4th power. We also had the situation where we have x squared, and then we raise that to a power. When we're doing that, we multiply the exponents. So that's going to give us x to the 6th power. Another situation that we ran into was the division. So if we had x to the third over x to the second, we know that this is the same as 3x's multiplied together. We know this is 2x's multiplied together, so that's canceling that, that's canceling that, that's leaving us this. But if we write it in terms of the exponents, it's going to be x raised to the 3 minus 2, which is the same answer. One of the things that I mentioned here was that anytime that we cross the division sign, so let's just say that this was raised to the minus 2, what we can do is to move this to the top. Now we're going to have x squared, or x to the third, times, we're moving it to the top, so we change the sign. So we have x to the third times x squared. At this point, we can say, let's add the exponent. So we're going to have x to the 5th power, and that would be our answer. So this problem was just an attempt to do some review of working with exponents. We have a few rules to remember, but if we remember those rules, working with exponents is not too bad. All right, I'm going to stop sharing. I'm going to stop recording.